If you ask pretty much anyone who revolutionized our view of the cosmos, they're going to say Nicolaus Copernicus, right? 1543, he publishes his groundbreaking work putting the sun at the center of the universe, not the Earth. It's the story we all learn in school. But what if I told you that whole revolution actually started almost 2,000 years earlier?
Everybody, meet Aristarchus of Samos. Way back around 280 BCE, this Greek astronomer came up with the exact same idea, a sun-centered, heliocentric universe. Yeah, you heard that right. That's a gap of nearly 1,800 years. So the real mystery here isn't who came up with the idea first. It's why this absolutely brilliant insight got completely ignored for almost 2 millennia. What happened?
And here's what's so incredible. Aristarchus' theory wasn't just some wild philosophical guess, a shot in the dark. Now, his mean book on the subject is lost to history, which is a tragedy. But his one surviving work on the sizes and distances of the sun and moon gives us a massive clue. It shows us his idea was the totally logical conclusion of careful observation and some really, really clever geometry.
And the way he did it was just pure genius. He realized something amazing. When the moon is exactly half full, what does that mean? It means the Earth, the moon, and the sun form a perfect right-angled triangle. And if you have a right-angled triangle, you can do some trigonometry. By just measuring the angle between the sun and moon in the sky, he could figure out the relative distances of everything. It's brilliant!
Okay, let's be real. His tools were super primitive, so his measurements were way off. He figured the sun was about 20 times farther away than the moon. The real number is closer to 400. But that's not the point. Not even close. His method was solid, and it led him to an absolutely world-changing realization about the scale of things.
So, based on his math, Aristarchus came to the conclusion that the sun was at least 7 times wider than our entire planet. And today, we know it's actually over 100 times wider. But even with his huge underestimate, think about what that meant. The implication was just staggering.
His logic was so simple and so powerful, it just made sense. Why in the universe would a colossal, gigantic object orbit a tiny, puny one? It had to be the other way around. The little Earth must be the one moving around the gigantic sun. See? This wasn't a guess. It was a conclusion that flowed directly from his data.
So if the ideal was so logical, why did it just fizzle out? Why didn't it catch on? Well, it turns out the ancient astronomers who rejected it weren't being stubborn or ignorant. They had some very powerful, common-sense arguments against a moving Earth, a lot of which were laid out by the philosophical heavyweight Aristotle.
I mean, just put yourself in their shoes. If the Earth is spinning and flying through space, why don't we all feel a constant, massive wind in our faces? And if you drop something, why does it fall straight down instead of landing behind you? But their absolute killer argument, the most scientific one of all, was about the stars. If we're moving, why do the stars look like they're in the exact same spot year after year?
This apparent shift they were looking for has a name. It's called stellar parallax. It was the geometric proof, the smoking gun, that they would absolutely expect to see if the Earth was in motion. You can actually see this effect for yourself right now. Go on, try it. Hold your thumb out at arm's length. Now close your left eye and look at your thumb against the background. Now switch. Close your right eye and open your left. See how your thumb seems to jump? That's parallax. The ancient Greeks looked for that exact same effect in the stars, and they found nothing. Zero. No shift at all.
So this left them with 2 possibilities. 1, the Earth doesn't move, which lines up with everything else they were observing. Or 2, the stars are so mind-bogglingly, absurdly far away that the shift is just too tiny to measure. Now, to his credit, Aristarchus picked option 2. But without any proof, it just sounded like a wild excuse to save a theory that didn't fit the evidence.
So it wasn't just that Aristarchus' model had some serious problems. It was also up against a powerful competitor, the Ptolemaic, or Earth-centered system. Now, we usually think of this model as this big scientific failure, but for over 1,400 years, it was an incredible scientific success.
Using this really clever system of circles rolling on top of other circles, called deferents and epicycles, the Ptolemaic model could accurately explain and predict all the weird movements of the planets, like that strange retrograde motion where they look like they're moving backward in the sky.
And listen, this is the most important takeaway here. For the actual job of an astronomer, which was predicting where Mars or Jupiter would be on a certain night, Ptolemy's model just worked better. It was way more accurate than any simple sun-centered model that used perfect circles for orbits.
And this slide illustrates why it was so darned effective. People kind of laugh at epicycles today, but they're basically just terms in what modern mathematicians call a Fourier series. It's this incredibly powerful technique where you can model any complex, repeating pattern you can imagine just by adding simple circles together.
You see, Ptolemy probably never even claimed this was what was physically happening up there. He treated it like a mathematical tool, a model. And as a predictive model, it was unbeatable for centuries. It wasn't based on a wrong idea, it was just really, really good math for getting the job done.
Okay, so now we can finally put all the pieces of the puzzle together. We can solve the mystery of why Aristarchus' brilliant idea had to sit on a shelf for 1,800 years.
First off, let's bust a huge myth. The idea was not suppressed for religious reasons. Nope. Ancient writers like Archimedes and even Ptolemy talk about it seriously. They don't call it heresy, they reject it based on what they saw as solid scientific evidence. It was abandoned by science for scientific reasons.
So it all comes down to two big things. First, the sun-centered model had these massive unanswered problems, and the big one was the lack of stellar parallax. Second, there was another model on the market, the Ptolemaic system, that was just more useful and more accurate for the day-to-day work. So science, pretty reasonably, went with the one that worked.
And for one last little historical twist, Copernicus himself knew all about Aristarchus. In his original draft, he actually gave credit to his ancient Greek predecessor. But for reasons we can only guess at, he crossed that reference out in the final version that went to the printer, basically hiding his debt to Aristarchus for centuries.
And that leaves us with a really powerful thought. Aristarchus had the right physical concept, but the science of his time just wasn't ready for it. The tools weren't there, the physics wasn't there. His idea wasn't wrong, it was just premature. And it really makes you wonder, doesn't it? How many other brilliant ideas are out there right now, just waiting for the rest of science to finally catch up?